Question number 4th, Understanding Quadrilaterals, Mathematics Class 8th, Chapter 3rd. Examine the table. Each figure is divided into triangles and the sum of the angles deduced from that. So let's examine the table. We are given with the figures. These all are closed polygons because all are made up of line segments and they are closed. That is, the starting point of the construction of this line segment ends with the same starting point. For an instance, if we start from here, we go like this, and the final point is the same as initial point. Therefore, these all figures are closed figures. And since they are made up of only line segments, they are all polygons. And we are given the sides representing each figure. Here we have 3 sides, 1, 2, 3, so they wrote 3. Similarly, here we have 4 sides, 1, 2, 3, 4. Therefore, it is a quadrilateral. Here we have 5 sides, 1, 2, 3, 4, 5. Likewise, here we have 6 sides, 1, 2, 3, 4, 5, 6. 5 sides means Pentagon, 6 sides means Heptagon. These are specific names for the polygons. Now, interesting thing is we are given with angle sum. You know very well from your previous standards that addition of all internal angles of triangle gives you 180 degrees. Therefore, this triangle angle sum equals to 180 degrees. Now, what happens in case of quadrilateral? We just studied in question number 3rd. You should watch that for a better understanding. And these dotted lines that are connecting two non-consecutive vertices are the diagonals. So here, these are 2 diagonals. Here we have 1, 2, 3 diagonals. Now what is happening over here? We have 4 sides in this quadrilateral, therefore we wrote 4. And we are subtracting 2 from it. And this complete is getting multiplied with 180. That is 4 minus 2 gives you 2 into 180. And when you solve it, it gives you 360 degrees. And we know very well from question number 3rd that sum of all the internal angles of a quadrilateral is equal to 360 degrees. Again, what is happening in Pentagon? We have 5 sides, so we wrote 5. We are subtracting again 2 from it. Hence, we are left with 3. And this is getting multiplied with 180. Again, we have 6 sides, so we wrote 6. We are subtracting 2 from it as well. That gives us 4. And we are multiplying that with 180 degrees. Now, if you observe, in each case, we subtracted 2 from the sides and then multiplied that with 180 degrees. We did not do it in case of a triangle. Well, here is the reason for this. These diagonals are dividing the figure into triangles. And since we cannot draw a diagonal in a triangle, therefore we are not doing this thing in case of a triangle. And now the question arises that why we are only subtracting 2 from the sides. Well, here is the answer for that. Whenever we try to construct a diagonal within a given figure, we cannot construct it to the consecutive vertices. Take an example of this quadrilateral. We started from this point. We cannot draw to this point and this point. This you know very well from previous questions, which again you should watch prior coming to this question. So we were only left to construct these 2 vertices since they are non-consecutive vertices. Again here, if we took this point, we cannot draw to this and this point because they are consecutive vertices. The only option left is to draw from this vertex to this vertex and from this vertex to this vertex. And since we are not able to construct our vertices in each figure to its nearby 2 vertices, therefore take any example of a polygon, pentagon, hexagon, heptagon or any n-sided polygon, we will be able to construct 2 less triangles than the given number of sides. Therefore, we subtract 2 from the given number of sides in every figure in order to find sum of all internal angles. For example, take this case of hexagon. We have 6 sides. We cannot draw to next consecutive vertices, that is this vertex and this vertex. Therefore, we have total 6 sides. We subtract 2 from it because we were not able to construct a diagonal to 2 vertices. Henceforth, the number of triangles formed inside this heptagon, that is 6-sided polygon, will be equal to 4. Namely this one, 1, 2, 3 and 4. With this understanding, you have understood it very well that why we are subtracting 2 in every case and not in the case of this triangle. Now the question says, what can you say about the angle sum of a convex polygon with number of sides? Well, these all polygons are convex because every angle within these figures is less than or equal to 180 degrees. Therefore, they are convex polygon. Again, for a better understanding, you should watch question number 1st, 2nd and 3rd of this chapter, Understanding Quadrilaterals. So in order to find our answer, we first draw a box. Since we have to find 4 questions, A, B, C and D, we draw the figure, we write the number of sides and we try to operate with our formula that we just derived here. So we are considering a part having 7 sides, that is heptagon. We are considering regular polygon here, or regular heptagon in this case. By regular we mean all the sides are equal and all the internal angles are equal to each other. Well, it comes out to be 128.57 degrees if we are going to construct a regular heptagon. Since we have rounded off, therefore we wrote it as approximately equal to 128.6 degrees. We just rounded 57 to its nearest tenth digit. Therefore this approximation sign came. In actual it is 128.57 degrees. Now if you multiply 128.57 degrees with 7 times, because we have 7 angles within, it will give you sum as equal to 900 degrees, which we shall prove using our this concept, that is constructing diagonals. Now we shall show you how we can construct diagonals and henceforth deduce triangles within this heptagon. Let's consider this side. We are very sure we cannot construct diagonals to its consecutive vertices, that is this one and this one. The only options are left are as follows. We can construct from this point as like this and like this. Again from here we can construct a diagonal like this, and the last one can be constructed like this. We cannot construct diagonals to this vertex and this vertex because they are consecutive to this vertex. This construction divided this heptagon into 1, 2, 3, 4, 5 triangles. So we can write it down as follows: 1, 2, 3, 4 and 5. In order to construct a diagonal, you can consider any vertex. The point is you just cannot connect consecutive vertices to that vertex. Therefore, we just represented this heptagon in our figure section. The only difference is we just considered vertex as this point. We are again telling you, you can consider any vertex. Just follow this procedure. Consider any vertex, try to draw diagonals to its non-consecutive vertices from that point only. Do not lift your point, otherwise you get puzzled. Now since we have deduced this formula, we write number of sides equal to 7. We subtract 2 from it because we were not able to construct a diagonal to consecutive vertices. Therefore we subtracted 2 and this gives us 5, and we then multiply it with 180 degrees. Why 180 degrees? Because each triangle has its total internal angles equal to 180 degrees. So 180 degrees for first one, 180 degrees for second one, and so on till fifth triangle. Therefore 5 into 180 gives you 900. Again, if you forget tables, 8 into 5 gives you 40, 4 is carried, 5 into 1 is 5, plus 4 is 9, and 0 as it is. So 900. With this, we have solved our A part. Likewise, we will do for octagon. That is, a polygon having 8 sides is termed as octagon. So we have constructed the figure like this: 1, 2, 3, 4, 5, 6, 7, 8 sides. Now we took this point and we try to draw diagonals. That is, one goes like this, another one like this, third one like this, fourth one like this, fifth one like this. And we cannot construct to this vertex and this vertex, you know very well by now, because these are consecutive vertices and diagonals can only be drawn to non-consecutive vertices. We have shown color coded that are formed after constructing this diagonal. So first one, second one, third one, fourth one, fifth one and sixth one. So we wrote 8 sides. We subtracted 2 from it. You know very well why we subtracted 2 from it. This gave us 6 because 8 minus 2 is 6. And since we constructed 6 triangles within this octagon, we multiplied it with 180 degrees and it gives us 1080 degrees. Now again, mentally, 8 6 are 48, 4 is carried, 6 into 1 is 6 plus 4 is 10, 0 as it is. So 1080 degrees. With this, B part is completed. C part, Decagon. A polygon having 10 sides is termed as Decagon. So we constructed it like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And remember, these all are convex polygons because each of the internal angle, that is this angle, this angle, this angle, is less than or equal to 180 degrees. So we wrote side equals to 10. For just a demonstration purposes, we again color coded the number of triangles formed within. We considered this vertex and we cannot connect to this vertex and this vertex. We can connect to this vertex, this, and this all gave us 8 triangles. Therefore, our general formula is write the number of sides. In this case, it is 10. Subtract 2 from it. This gives us 8 because 10 minus 2 is 8. We multiplied it with 180 degrees. It gave us 1440. Again, for the multiplication purpose. 8 8 is 64. Therefore, we wrote 4. 6 is carried. 8 into 1 is 8. And 8 plus 6 is 14. And plugging 0 as it is. Therefore, in case of Decagon, that is a polygon having 10 sides, the sum of measures of all the internal 10 angles will be equal to 1440. This is just an example. This is not a decagon. Consider this decagon. That is, sum of these all angles, all 10 angles would be equal to 1440. Now the question arises why we are studying this. Well, in certain day-to-day lives, we have to construct such figures in our engineering field. And in order to construct such figures, we need to know the angles. So we cannot always remember the angles within. Therefore, this general formula has been deduced. To get you a better view, we just enlarged this figure. Here we have 10 sides. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Now we took this vertex and we tried to construct a diagonal. So remember, we cannot construct diagonal to its consecutive vertices. That is this one and this one. So we constructed like this, that is all other non-consecutive vertices. This gave rise to formation of 8 triangles. 1, 2, 3, 4, 5, 6, 7, 8. So we subtracted 2 from the number of sides, that is 10 minus 2, it gave you 8, and we multiplied it with 180. And you know very well how 1440 came. That was your C. Now the D part, that is n sides. So this will give us general formula in order to find sum of internal angles of a polygon. So we wrote n sides. We know we have to subtract 2 from the sides. So we subtracted n minus 2. We wrote here n minus 2. That is these number of triangles formed. And we need to multiply with 180 degrees because each triangle sum property equals to 180 degrees. With this, we found our general formula. So remember, in your lifetime, if you are given with any polygon and you are asked to find sum of all its internal angles, you just subtract 2 from the sides, and whatever you get, you just multiply it with 180 degrees in order to find sum of all its internal angles. And in mathematics, if you are given any formula in terms of variable, it is termed as general formula. Remember that as well. So in this question, we learned a general formula, that is n minus 2 into 180. That gives us sum of all the internal angles of a polygon. With this, our question number 4th of Mathematics Class 8th, Understanding Quadrilaterals, Chapter 3rd has been solved.